let's go to the room URL.
Thank you for reaching out to NHS Blood Testing Services. I'm Phoebe. Could you please provide your full name? Thank you for providing your phone number, Abhijit. I'll now check your patient records. Please give me a moment. Thank you for your patience, Abhijit. According to your GP's instructions, you're scheduled for a fasting blood glucose test for diabetes screening. This means you'll need to fast for 8 to 12 hours before your test. Would you like to book an appointment now?
Whenever I see any open source project that helps power up voice agents or multimodal AI agent use cases, I really love this project to check them out in details. And that's what I've been doing for the last, 3-4 hours. It's already 1:30 a.m. And I think I have got some idea about this new project, what I am going to explore in this particular video. So without much further ado, let's go to the code tutorial and see what this is all about. Now, the project that we are going to explore today in this tutorial is Pipecat. Many of you have been asking me about this project and to explore this project for a long time, especially when I started looking at the LiveKit and I was using LiveKit. But then I kept on ignoring this project because when I checked out the project first time, I saw this BSD2 clause license, and generally whenever I see some clause license, I usually tend to avoid it. But then it was my ignorance that I didn't read through the actual statement of the license, and by the looks of it, it doesn't actually restrict any way using this project commercially. Now that I read it through the documentations, whatever possible in few hours, I have done that now, and I'm not a legal expert, but in my view, it is a project that can be used commercially. So that took my interest, especially because I have been creating my own voice AI agent platform, and I am leveraging WebRTC, and that's what I have been championing about for a long time. I have been telling you through this channel that please use WebRTC framework if you're trying to create any multimodal or voice AI agent, and don't use WebSockets only. And that is where I have explored LiveKit in much more greater length. I created almost 7 to 8 videos on LiveKit in this channel. If you are first time into the channel, or if you're just learning about the voice AI agents or multimodal use cases, I have covered numerous such use cases in this channel. And in fact, I have now created this one-pager website where I have captured all of these projects one by one that you can check. And all the code tutorial is absolutely free, and you can also join the free community. So before we proceed, make sure you hit that subscribe button to the channel, because I generally cover all these different business use cases with multimodal AI agents in this channel. And if you are someone who is looking for the Pipecat project in detail, this is the first video where I'm going to explore the Pipecat, how it works, and then I'm going to show you a live demonstration with a particular code that I have created for the last few hours, and we're going to test it, how that entire thing works. And in the subsequent videos, we are going to explore different other features that this project offers, and we're going to explore how can we actually squeeze out the juice out of this project for our own use cases. So without much further ado, let's go to their documentation and let's see what this project is all about. So as the project says, it's a framework for building voice-enabled real-time and multimodal AI application, and that is actually true. I checked the documentation, it actually worked based on WebRTC, and this is a project that is, I think, created by daily.co. I didn't know until one of you actually told me that they also have this particular agent or WebRTC framework using which they have created this project, and they are actually delivering this voice and video application. That really intrigued me to check out their page, and I was really impressed, I would say, because it kind of simplified a little bit. Because I have seen the LiveKit stuff, and I know LiveKit offers a lot of the features, and I'm not too sure whether this project offers all those features yet, but it offers most of the basic ones that you need to run a multimodal use cases. I would straight away go to the core concepts, because that is what you would really need to know. The way it works is they use a concept called frames. So they have frames, they have processor, and then they have pipelines. So this is like their entire architecture looks like. So basically, whenever there is an input coming in, it goes through their speech to text service. Then they have a context aggregator, which is nothing but the input as well as the LLM context, like the system context or any memories. Then they call the LLM service, which produce the output that goes through the TTS output, and that delivers through the transport output. But you might say, hey, this is very similar that we have seen with normal like multimodal AI agents, right? Which is true, but then they process everything as a frame. And what I mean by frame is like if you think of a conveyor belt where items are moving through the conveyor belt, so each of the segment, like the text, the audio, the speech to text, each of these segments, they transform into a frame and then they send those frames using the WebRTC channel. As a result, because they are using WebRTC as a backbone of or the framework, it actually works really, really faster. And it actually gives you the real-time feel, even though if you use a voice pipeline sort of agent. But I was more interested in creating a real-time agent like using OpenAI real-time or similar speech-to-speech model. And I would say I am a bit impressed with the way it is working. So this is frames or containers for data moving through your application. It's like packages on a conveyor belt, exactly how I have told. So audio data from a microphone can be a frame. Text from transcription is a frame. LLM response is a frame. So they basically process each of these output or input as a frame and then they send it through the WebRTC layer. So here they say that frames can flow in two directions. One is downstream, which is the normal processing flow, like the way you would want to process the process and audio data or process the text data. So that is a downstream, and then upstream is for errors and control signals. What is control signals is like, let's say participant joins a room, that's a control signal. If a participant leave a room, that's another control signal. So for that also we can use frames as well. Then they have something called processor. Again, it's just the services. So processors are like, let's say your speech to text model. So when you embed your speech to text model with the Pipecat project, that the speech to text service becomes a processor. Basically the processor takes an input and produce an output. As simple as that. If you have an image generation processor, that means it will take a text input and it will generate an image output. And then there is a logging processor, which might just watch all the frame that is going through the WebRTC channel and it will produce the logins. And then they have pipelines where they are putting all of the processor together. This is really important to understand because before I go to the code and I'll actually show you, you need to have this understanding between what is frame, what is processor, and what is pipelines. It's a bit different term, although I would say contextually it is really, really same. That's also, as I said, how it all works together is user speaks into their microphone, the transport converts the audio into frames. So frames are more sort of, I would say, they have wrapped everything as a frame in a library. So regardless of whether it's a text input or it's a voice input, because it is easier from a programming point of view to wrap things into a singular model to process it faster. And I think that is what they have done it. And basically, in the processing layer, they process the frames, and based on the different processor, if it is LLM processor, it's process the text frame. If it is a TTS processor, it processes the text frame and produces a speech output, and similar like that. And that's all really I wanted to cover as part of core concept. Now we will straight away go to the code that I have created and I'll show you. You can go through the website at docs.pipecat.ai and go through all of this example and stuff. I will anyway cover this in upcoming videos in much more detail. I don't want to just take an example and run it through. Instead, I would really like to see what is it there which can be used in a business context, and I generally bring in this channel. So that is the reason why I didn't just take one of their example and run it. Now we will go to a real life scenario that I have created and a real life business case using Pipecat, and I'm going to show you. So this is the code that I have created, which OpenAI's real-time API, and I'm going to quickly run through the code so that you understand how this is all working. Actually, I wanted to also show you something before I go there, which is, I think here. Yes. So in the deployment pattern. So this is really essential for you to understand how the entire architecture works. It is almost similar how LiveKit works or how general WebRTC work. And by the way, if you don't know what WebRTC, how it works, I have covered a really long, like 40 minutes video detailing everything that you need to know about WebRTC and LiveKit and why you should use WebRTC. Please go ahead and check the video. I will also attach the link into the description because that is really essential for you to understand if you are trying to build any kind of AI agents really, or multimodal AI agents specifically. Now, how Pipecat works a bit differently is, let's say you have your end user, and then the end user would call, or your client, I would rather say, rather than end user, I would say these are the client, which could be your React application, or it could be the actual end user as itself using the browser. So it first calls the HTTP service that you need to create when you create any kind of bot or Pipecat bot or the Pipecat agent. So Pipecat agent itself doesn't run by itself, so it needs a bot runner service which would initiate this Pipecat bot. And the runner service also have a server URL that is created with the runner service. So whenever you hit the runner service and you will say, hey, get me the room information, then the runner service calls the bot service, and the Pipecat bot actually connects to daily.co server and create a room and return the room information back to the end user, and then end user uses that room to connect to the room, and then the Pipecat bot uses that media transport layer using the room to transport the output basically. If you're still confused, let me actually quickly draw it for you. This is the previous video drawing. Let me just drag it. So basically what is happening, this is, let's say, your client, and then you have the server here, and then you have the agent. Just make it this agent. So this is client, this is the bot runner, which also initiates a server, and this is the Pipecat agent. I wouldn't say it bot, I would rather say it agent. Now, when you are first time requesting to the server connects to the agent, and the agent goes to the daily.co web services or WebRTC service, it gets back the room URL with the token, because the agent have the daily.co API key and tokens and everything. So using that, it actually creates the particular room, and then it returns the room information back to the client, and then client uses the room information to join that room. So this is the room where client joins, and then the Pipecat agent uses transport layer to sort of respond through that particular room. So that is how the entire thing works. So it's very easy, and the best part is once this room is created, so let's say this room is created, and because it is running on WebRTC, that means multiple participants can join. So there could be numerous clients, right? So maybe you have 4 clients, maybe you're creating a Zoom-like application or meeting room-like application, where each of your client, like your browser client, will use the same room URL, and it can join the same room. So that means it can support multi-participant in a single room, and you can definitely have the agent serving different clients. Let's say you want to create an application where different people will come into a meeting, and the agent will just track the meeting transcription and create an analysis, something. You can easily do that using this protocol. So that's how this thing is working. Now let's go to the code and understand. So as I said, we need to have a bot runner. So that is why we have this runner class, or the runner Python file. This is basically just having the room URL and room API key, and it's calling the api.daily.co meeting tokens at this endpoint, and from there it provides the API key and everything, and it gets back the room URL. And then we have the Pipecat agent, which also connects to the rooms using the same API key. So that means the agent is running as an independent process here, and it also uses the token, the same API key and everything, to join to the different rooms. So that means if you create multiple rooms, like there, let's say this client, so let's say this client makes a separate call to the server and it gets a new room here, and this client joins this room. So if this client joins this room, Pipecat agent can actually serve multi-threaded, so it can actually connect to this room and serve as well, because it is independent. It is using its own meeting tokens and rooms, and it's basically, that is how it is actually connecting to different rooms. So what I mean to say is you can run multiple rooms in parallel if you're trying to create any such application. As a particular code, it's very simple. What I have done is I created a few functions, because it also supports function calling. I created a few functions giving the properties and everything, and then we have the main function where we have the server running, and then this is the daily transport library using which we are connecting to the daily transport server. So what you need to do is you need to go to the daily.co and then register yourself. You can use, I think, daily video or bots, doesn't matter, and you will come to this console. I think use this one. I will attach the link, which is dashboard.daily.co. Sign in yourself, and then from here, if you go to developers, you can create an API key. So this is like one of my API key that I've created, and it has access to all these endpoints. And then you have rooms. So I have been testing, so I have already created multiple rooms. You get a free tier. So as part of free tier, you get up to 10,000 minutes of call, which is really double what LiveKit offers. So LiveKit offers, I think, up to 5,000 minutes for free, but they're offering 10,000 minutes, which is really generous. But there is a limitation. You must remember that there is a limitation of rooms. So you can only have up to 50 rooms, and you need to do some room management, and I'll show you how. For example, it's saying I've already used 10 rooms, whereas I've only created one agent. So that means every time, as I was showing you in the diagram, that every time a new client can create a new room, it's not going to actually delete the room automatically. You have to manage it, not manually. Of course, there will be some automated way, which I will explore later and tell you about it. So these are the different room services, and you can also enable recording. So I think that needs some premium tier where each and every recording will be saved, and you can have $50 trial credit. I haven't used it. I will probably use it in the next video. And I saw they also have pay-as-you-go options, so I will also try that out in some future videos. So again, subscribe to the channel if you want to see more on this particular project. This looks promising to me so far. Let me actually show you how you can run it. Now everything is set. You don't need to do anything there. Just have this particular file and have the runner.py file, and you have the requirement.txt. Just create a conda environment and just install the pip install -r requirement.txt. Just install it, and once you install it, everything will be ready. All you have to do is just run this particular script, and that will actually start your runner, as well as it will join a particular room, and then you get the room ID. Now in this case, I've created an NHS appointment bot. So as you know, in UK NHS, you have different phlebotomy center where people go and give their blood. So I was just thinking maybe we could create an appointment bot for them, and that's what I did. And I'm using the GPT-4o Mini real-time preview model, because that is comparatively cheaper when you use any kind of real-time API. And there are different functions that I have registered here, and then the context, I'm just giving hello, I need to book a blood test. You don't need to keep this context, that's fine, but I've just added it. And so this is the session properties, which is used when we are creating this OpenAI real-time beta LLM service. We have given the session properties, and within the session properties we have specified the instruction, which is the system context, and we have a turn detection, but this turn detection is very basic. So what we are saying, if there is a silence of 800 milliseconds, that means this is now the agent's turn. So agent would know that user have stopped talking. But I haven't found the interruptions like we have found in the LiveKit so far, but I'm sure it will be there. I don't want to say that it's not there. I haven't really checked out the entire project. This is really a big project to check. and I will do further videos on this one, on different features that it has. And as I said, whenever there's a first participant joins, it's basically, it captures the transcriptions and it runs the pipeline where the agent joins and basically runs the pipeline to process the user. That's it. It's very simple code, and at the moment the tool calling is not actually making any tool call. I've created a sample response which it is randomly returning back, but of course you can add different APIs to it instead of a fixed response that I have done, because I was just only doing the testing. This code will be available for completely free, so use the link in the description below and download the code. And let me actually join the room and test it.
Hello, I'm Phoebe. Thank you for reaching out. Could I please have your name to start with?
Yep, my name is Abhijit. Can you hear me? Let me refresh it. Hey, can you hear me? Phoebe, can you hear me? So as I have restarted it, I can see that it has closed the previous consumer. I don't know why it is not able to listen to me. Let me go to an incognito. Try it. Hey, can you hear me? Hello? No, this is one of the issue that I have seen with this Pipecat agents, and I don't know if it is because I am doing the video recording and also running this in the same system or not. So let me try another room.
Hello, I'm Phoebe. Thank you for reaching out. Could I have your name, please?
Yes, my name is Abhijit. Can you hear me? I can see it is able to detect when I'm speaking, but I don't know why it's not working. Hey, can you hear me? Not sure. So that's a problem. I'm gonna actually work on this. I don't know why it's not working. It was working. It could be also a reason because my microphone is now being used for the recording. So maybe that is why it was not responding. Also, the other problem was I was trying to create a client using their SDK, but it was really challenging even for me to create the client. What I will do, I will try and run it separately later on, retry the demo, and if I'm able to create the demo before I edit this video, I will attach that. But this has been a problem. I just wanted to be honest here that this is what I have seen, and it may be because I have missed something when creating the agent, because I just followed the documentation and created the agent. So maybe there are some settings or some configuration that needs to be placed properly, and I will explore on that honestly, and I'm going to put it there. But regardless, please use this, test it yourself, and let me know if you're able to make it work. One quick update that this code is now working, and I had to make a few changes to make it work. I realized that later, and this is one of the reasons why whenever you are using any AI code editor or AI agent like a cursor or anything, you have to be really careful because when I was making the changes to the code, I asked the cursor to create the docstring. I don't know why, but it made some changes to the core configuration files, which is this daily transport configuration file, and that actually caused the issue. So basically, what I had to do to fix it is I had to enable the transcription enable to false. And I had to also add this start audio paused to false. And the reason why I had to do that is because I'm using the OpenAI real-time service here. So in a real-time, when you are using real-time service, not standard voice pipeline, the real-time service itself has the capability to do the turn detection, to basically detect if there is a pause in user's input and all those things. So you do not need the Pipecat to actually control that. Your Pipecat should just be sending the packets to the OpenAI real-time service and let it do all the decisioning. So whether the audio is getting paused or whether there is a transcriptions that is needed for the voice input, it should be decided by the OpenAI real-time API, not the other way around, not the Pipecat project itself. But if you're using a standard voice pipeline, you need to set the audio paused as true. You need to set the transcriptions and everything. And I think that is the reason why it was failing. So what I'm going to do is just come out of this, and I will retry again, and I'll show you it is working right now. So let's go to the room URL.
Thank you for reaching out to NHS Blood Testing Services. I'm Phoebe. Could you please provide your full name?
One other thing that you should also do, just reduce this mic noise, because otherwise it sometimes captures the noise and it thinks that there is some voice input. So please make sure you reduce that one, and then it should work. Hi Phoebe, my name is Abhijit.
Nice to meet you. Abhijit, can you please provide your phone number so I can assist you further?
Yeah, my phone number is 071234568789.
Thank you for providing your phone number, Abhijit. I'll now check your patient records. Please give me a moment. Thank you for your patience, Abhijit. According to your GP's instructions, you're scheduled for a fasting blood glucose test for diabetes screening. This means you'll need to fast for 8 to 12 hours before your test. Would you like to book an appointment now?
Yeah, sure. Let's do that.
Your appointment for the fasting blood glucose test can be scheduled at the following available times: 9 a.m., 10:30 a.m., 2 p.m., or 3:30 p.m. Please remember to fast for 12 hours before your test. Which time would you prefer?
I would like tomorrow 9 a.m.
I've booked your fasting blood glucose test appointment for tomorrow at 9 a.m. Please make sure to fast for 12 hours before the test and only drink water during that time. If you have any questions or need further assistance, feel free to reach out.
Yeah, sure. Thank you.
You're welcome, Abhijit. Take care.
So as you can see, it is now working, and that's happy days. So again, please check out the latest project code. I will anyway update this code to the repository so that you can actually have a look and improve upon it. So let me know again what you think of this and what is the possible use cases you would like to build with these Pipecat agents. There is a lot more features that I need to test on this one. There is a lot of issues that I have seen when I'm testing this out, and I was writing this code, and I'll work on that and I'll update to the channel. So now I will let you go to the next section of the video. The only one thing, again, as my own opinion, I would say, is this is not really still close to LiveKit. The main reason is being the LiveKit is an open source project. It's completely open source. That means you can even self-host your own WebRTC server, and I have covered about it in previous videos how you can self-host LiveKit. But this Pipecat application or this Pipecat agent needs the daily.co WebRTC server, and I don't know whether daily.co provide their WebRTC code open source like LiveKit. So that means even though Pipecat is an open source project, you would still need the daily.co or WebRTC server to actually make it work, which is not bad thing. I'm not complaining about it, which is actually a good thing, because managing your own WebRTC infrastructure is really painful, I would say. So it's better to have a trusted or a secure WebRTC framework or infrastructure run by a provider that we can use. But yeah, this is not per se completely open source project, is what I feel, or what my opinion is. Regardless, let me know what you think about this project and what you want me to cover more about this project, and I will definitely check out this project for my cases, as for my own voice AI agent SaaS that I'm building. So as part of that, whatever I would find, I would definitely bring more videos on this one, in this channel. So with that said, I'm going to end this video. I really hope you have had some learning. If yes, give this video a like, share this to your friends or to your other colleagues or other people so that they also learn about these new technologies. And don't forget to subscribe to the channel and join the free communities. Please take care, and I'll see you on to the next one.